Welcome to the Maine Science Podcast. I'm Kate Dickerson. Today's episode is a conversation I had with Bob Lindyberg, CEO of Global Secure Shipping, a startup company based in Old Town, Maine. Bob and I go way back. We've known each other for over 40 years. It was a joy to talk shop with Bob and learn about how he got to Maine and into engineering, not to mention his cool work on shipping solutions, which is not an obvious pivot for someone with a background in civil structural engineering. Our conversation was recorded in January 2025. I hope you enjoy it as much as I did. Bob, welcome to the Maine Science Podcast. You are easily the guest that I have known the longest in my life. We've known each other for decades and decades because we both grew up in upstate New York. And I'm sure you and I never talked in high school about science and engineering paths. We talked about classes we were in. So lo and behold, when I get to Maine, you're here and an engineer. So I know what you were like in high school. I have no idea how you got on the engineering path or how you got to Maine. So why don't you tell us?
That's actually a really good question. You and I were both definitely in the college track classes together. I think in the last 2 years, I don't think I recall taking a class without you. We took all the requisite physics, calculus, 2 math courses in senior year. And despite all that, at the time, as an 18-year-old male, I probably had little to no interest in science or math or engineering, although I was good enough at it to pass courses without doing much homework, which you may recommend from some of our teachers' criticisms of me. I was fortunate to be accepted to Union College. When I got to Union College, obviously, for the benefit of your audience and really kind of telling how people can change and evolve, my first couple semesters ended up in academic probation because I hadn't really discovered a passion for science and engineering, and the skills to get there really weren't there. But soon thereafter, I decided that, civil engineering looked pretty cool because, there's concrete and there's steel and people wear hard hats and big structures are kind of neat, bridges, buildings, et cetera. So I found that kind of passion and really devoted myself to trying to making my way through and building myself as a civil engineer and getting a civil engineering degree. That's really kind of where my engineering started. In terms of passion for research, science, and engineering, fast forward to getting out of college, I went to the State Department of Transportation in Maine. If you recall, back in 91, there weren't many jobs being offered.
Such a good time to graduate.
Yeah, there was a dearth of opportunity, but fortunately, I got a great opportunity with the State Department of Transportation. And as such, over the next year or two, was exposed to the University of Maine and the University of Maine's graduate program. Took a year off to get a master's degree, and that year really opened my eyes to R&D and science and technology, going beyond traditional civil engineering, and really what that meant, what that could do, and how exciting it was. And from there on, I got bit by the bug. I went for a master's. I never intended anything close to a doctorate, but I got that and continued on for, probably 17 years at UMaine and really enjoyed every bit of it.
So it's interesting. Do you have anybody in your family who's an engineer? How did you connect the dots between buildings and bridges are cool and I will go into civil engineering? And I ask that, and I've said this before on the podcast, I didn't even know what an engineer was until I was a sophomore in college and I was at an engineering school and I could never figure out how anybody knew what they wanted to do. I thought it was really cool, but I was like, how do you even know? So how did you get that?
There were people. My father was a chemical engineer. His father, although he was not degreed, he did not have a degree, of course, coming of age in the 30s, that was not unusual, was involved in electrical engineering and early telecom. When I looked at what they were doing and talked about chemical engineering and that electrical engineering, neither of those really spoke to me at all. They were obviously great careers. They enjoyed them. They put me through school, but that really didn't speak to me. It wasn't until I got to Union and really understood that I had to make a choice and find a passion. The passion of bridges and buildings looked pretty cool. I think one of the things that cemented that passion is, a mutual friend of ours, a mutual classmate of ours. His father was the deputy chief engineer of New York State DOT. And in 1989, through a happenstance meeting, he knew that I was now in civil engineering. He offered me an internship for construction engineering at the Department of Transportation. They hire interns in the summer to come out and do construction monitoring. And that really got me out to it and on the engineering side and was really instrumental. And this is pretty cool. This is something I want to get involved in.
So this is great. You've already told us about so many things that people need to know about. One, you had no idea what you wanted to do. Two, you're on academic probation. something I think we can all relate to. I never got to the level of academic probation, but I can definitely tell you I had great terror in the idea of how am I going to pass these classes? And then using a network in a way that you may not have thought of, right? Like, I don't know about you, but it never occurred to me, certainly when we were in high school, that our parents did anything that would be at all useful for any of us. So it's a good reminder, right? Certainly as adults now and with our own adult children to just remember that where you find opportunities can literally come from anywhere.
Right. And I will give credit to the network of our families. I did not seek out to utilize that network because at 19 years old, I really wasn't aware of it. But they were looking out for us, just like you and I do with friends and family, friends, kids, and within our network. When we see opportunities, we let people know and try to foster that talent. And I'm eternally grateful to those people who did that. And they really showed me what the importance of a network was.
Okay, we glossed over it, but you spent 17 years at UMaine doing really exceptionally cool composites work, which I would argue composites as a key factor of engineering has really come into its own in the span of our professional careers. If you could explain, number one, kind of what the composites aspect is with regards to the engineering, and then anything that you are able to talk about that you did there. And I know you did a little excursion away to North Carolina, and then we got you back.
That's a great question. To clarify a little bit, composites has been around for better parts of a century. But up until the 80s, 90s, composites was advanced fibers, glass fiber, carbon fiber, aramid fibers. Composites was real advanced stuff, aerospace, which is very expensive, and marine work. And as a boat owner, I can tell you boats are very expensive. The composites industry began looking for ways that composites could be utilized in infrastructure, bridges, buildings, etc. And the first thing that I was drawn up to and what became my doctoral thesis was reinforcing low-grade wood with fiberglass. So composite beams, the glue laminated beams, which we've probably all seen, large wooden beams laminated together by 2x4s, 2x6s. They've been around for decades, but they require some high-grade wood, especially in the areas where it's most stressed. Maine, at the time, had a huge amount of wood. The majority of it, though, was for pulp and paper. And what wood there was available for structural use was certainly not the highest grade that would lead to really competitive glue laminated beams. And so the University of Maine started doing research on, can we take small amount of composites, really 1 to 2% by volume, and increase the strength of low-grade wood. And long story short, my doctoral research really showed that you can actually, with that 1 or 2% addition of composites, so 1 or 2% to the volume of an entire beam, that could double the beam strength.
Can you explain the difference between what low-grade wood would be and higher grade, and like what the composite is doing with that?
Sure. At the time, certainly, and even now when you buy high-grade glue-laminated beams, they consist of southern yellow pine and species from Douglas fir from the far west. They grow very tall. They've got some good tight growth rings and density, and certainly graded well. You can identify that there's grades without much defects, including knots and whatnot. Maine's woods certainly produce some wood like that. Like as we said, most of the wood produced is more towards the pulp and paper grade. So there are more knots and defects and different grain characteristics. And it means that when used in a glue lam beam or overall, our strength of a hemlock board is generally of a grade number 1, which means relatively few knots, is generally less than the strength of a Douglas fir number 1. So the resource Maine had and still has is hemlock, pine, etc., that, while very useful, pulp and paper, and also useful in framing, are lower strength than the traditional grades used. And so adding reinforcement, when a beam bends, the top of the beam goes into compression, the bottom of the beam goes into tension, and the beam will typically fail in tension because it is weaker in tension somewhat than it is in compression. And that holds true for the lower strength species in Maine. However, just like reinforced concrete, if you put the fiberglass reinforcement at the bottom of the beam to reinforce it in tension, in a small amount, again, this is like 1 or 2% of the entire beam volume, that will adequately reinforce it in tension so that it starts to perform just like the higher grade quality woods out in the West that are produced commercially.
How long did it take you to figure out you only needed 1 or 2%?
Early on, it was some early testing really showed that somewhere between 1% and 3% was going to do a lot. But my research and my doctorate really looked at coming up with that answer. And one of the issues is that wood is very variable in terms of its properties. Even within a species and a grade, it's very variable. So how much are composites going to improve its performance? And then ultimately, what can engineers use a design guide for using those beams? And so I developed modeling methods and an analysis method that took into account all that variability. And I was able to model beams really across the entire spectrum for use of glue laminated beams for bridges, for buildings, et cetera. And with different types of wood, different types of grades, et cetera, different reinforcement levels. We validated that model at key points to make sure, not the whole thing across the board, but at key points to make sure that we bounded it. And from that model, we were able to determine that 1% to 2% reinforcement was improving it, up to 100%. We were also able to, through that process, and part of the back-end process of this was developing and gaining approval in the building codes and bridge codes, which we ultimately did. So I started this work on my doctorate sometime in around 95 and was awarded my doctorate in about 2000. And I recall, as you probably know yourself, getting code approval for things like the bridge code, AASHTO bridge code, and BOCA, et cetera, is a long, onerous process. Sometime around 2007 or 8, I went to the final meeting for the American Association of State Highway Transportation Officials that approved the final use of reinforced glue laminated beams in the bridge code. That was almost a 20-year journey. I started it with a full head of hair. I ended it with about what you see right now and a couple of kids.
Yep. I was just thinking it's a whole birthing, parenting, growing up process to get that done. So I'm going to make you jump ahead. You are doing something right now at Global Secure Shipping that does not involve dosing wood, basically, right? But it is super heavily composite based. I had the great good fortune of being there at the ribbon cutting for your facility, which I love going to plants and different manufacturing places because I find them deeply fascinating. I'm constantly captivated at the amount of technology and intense intellectual property that's patents and stuff, but more like the thought that people put into manufacturing floors and other things. So I'm jumping you ahead. If you can tell us as much as you're able to about what you're doing now and kind of how it relates to civil engineering in a way that most people don't think about, I think your background in civil engineering leads to this in a lot of ways.
Yeah, that's a good question. So Global Secure Shipping is commercializing a patented humane technology for secure shipping containers. I think everybody's probably seen these containers. They're on trucks, on trains, on ships. Generally, they all have a steel frame, except for ours, all have steel sides, corrugated sides. They can be put on trucks, they can be put on a train, and they can be put on a ship. And this was back in the 1950s, I believe, that containerized shipping revolutionized the shipping industry, and now pretty much that's all the shipping that's done. Back in 2003, the Department of Homeland Security was concerned with, among other things, border security and weapons of mass destruction being smuggled into the United States. And they put out an RFP, and they determined that almost all of the containers coming in are not secure, which means that they may have a lock on them, but you can cut a lock. You can also, with steel sides, cut through the sides. In addition, and containers were not being inspected. They didn't have a lot of resources to inspect containers.
And I'm going to just interrupt here.
Sure.
If people have not seen the size of cargo boats with the shipping containers on them, if you haven't seen that, it is an extraordinary feat of engineering to fit hundreds and hundreds. So, the resources necessary to inspect every single one of those, it would be a lot of both personnel and money.
At the time, I think they did a study that DHS could mobilize all of the CBP, Customs and Border Protection, and everything, and maybe inspect, 1 or 2% of the containers coming in. Now, I think that number is, with some technologies and whatnot, has risen to 5%, a little bit more. But the concept was that if the containers are secure and can provide the shipper with a notification if your container has been opened or tampered with at all, or penetrated through the side, then that could, in cooperation with CBP programs, that could lead to better border security. Because shippers are generally They're shipped for government or non-government. They're doing business. They have generally a secure facility that they load a container in. But then when the container goes out in the world, anything can happen. So if the container will alert you if it has been opened, that's a huge asset. And that would lead to, well, maybe you would know which containers to stop and inspect as they come across the border. Alternatively, you would also know which ones just to pass right through. You go, because we have proof that it was sealed and it has not been opened. So UMaine went through about 10 years of technology development between 2003 and 2013 to develop a shipping container with a steel frame, but it has composite sides with embedded sensors. And so that if you penetrate through any of the sides of the container, the door, the walls, floor, the roof, it will give you an alert. Also, if you open the door, it'll give you an alert. And it'll also track the container worldwide. So it started with a concept half-scale container in 2003, and then ended up in 2013 with a full-scale container, a prototype manufactured at UMaine that had received ISO certification. And for those not in the shipping industry, if you don't have ISO certification for your container, it is not allowed to go anywhere near a port or a ship. So you have to have that. If you look at the front of a container, there's a stainless steel plate, and that is your ISO certification. So if you don't have that, you can't play. So fast forward, about 5 years later, the president determined that secure containers were a critical national need. And a presidential determination was put in place to establish a domestic container manufacturing facility in the United States. The University of Maine personnel spun a company out. There was a contract that was put up for competition. They competed for and won the contract. And it was awarded in 2018. I got a call in 2019. As you said, I was down in North Carolina. I got a call and they asked if I wanted to come back and take this on and really start the company and grow it and get it, complete the contract and really create jobs here in Maine. My work at UMaine up till then had really been more on the R&D side, although I'd worked closely with companies who were commercializing. Now this was an opportunity to come work on the commercialization side and take the prototype technology and then do the development R&D to make it manufacturable at the rate of 1,000 containers or more per year. And that's what we're just completing right now. And the groundbreaking that you attended a couple months ago was really the official completion of that.
So I don't mean this badly, Bob. Why did they call you? What was it about your background and what you'd been doing since you left UMaine that they were like, who's going to really get this through? And I'm asking that because it's not a direct link to civil engineering research work, but, you clearly had the skills. What was it? And then alternatively, what was it that you found compelling beyond what you just said, if anything else, besides the fact that you get to do commercialization and run a business?
Well, I'll answer the second question first. There is a link to civil engineering. These containers are very structural. They have to meet very rigid requirements, and that requires structural analysis of what is now a composite structure. And that's my specialty. I spent 17 years doing that sort of stuff at the University of Maine and enjoyed it very much. And in addition, I love Maine and always been passionate about R&D to commercialization to grow Maine's economy. And so coming back in 2019, having the opportunity to come back from North Carolina and take an active part in creating real jobs in Maine and doing fun engineering was a hard thing to pass up. Why me as CEO? My career path, kind of as we discussed, I didn't know what I wanted to do, decided I wanted to be a civil engineer, focused myself on that, then got into R&D, really spent a lot of time in R&D and developing structural products and working with companies to commercialize them. After that, though, in my time in North Carolina, I left and joined a company and took over profit and loss. Really was a senior executive for 8 years on an engineering company in the Research Triangle that was in charge of the full business of at least my P&L, which ended up growing to be about 250 people. I gained 8 years of profit and loss responsibility and operations on the business side. And so that combination of an engineering background and experience with composites, I understood the R&D and actually early on had participated in and managed peripherally the initial R&D project, and then had P&L, so could actually have the experience as a CEO to stand up a business. I think those are kind of three kind of unique things that made them come to me and said, hey, and then of course the folks that founded GSS at the University of Maine, they knew I loved Maine and always wanted to come back. So
yeah, I'm glad. I'm totally psyched about it. I was just curious, I think if someone who first starts listening to this is like, but wait, the guy was talking about bridges and now it's containers. So I have two other questions I'll ask you. It sounds to me like the idea in 2003 was ahead of its time from the perspective of not only had things never been done with the idea of sensors and things being identified, but it wasn't even clear that that was a path that was possible. Does that sound accurate?
I think it wasn't clear that there was a need. Embedded sensors and composites had been around for aerospace and other things and infrastructure, for aerospace for decades, for infrastructure for about 10 years. But really that application, what is the need for secure shipping? And 9/11 kind of elevated that need. The possibility of nefarious material getting smuggled into the United States and causing harm in a container was now a risk. So that elevated itself, if that makes sense.
Yeah, yes. And then the other one, it seems to me, once you start thinking about secure containers from the perspective of national security, the next obvious step is that people would just want to have secure containers for whatever they're shipping so that they know whatever's in there is safe. So is that part of what your mandate here is? It's not just a national security aspect, which is, of course, important, but it's also making sure that people's actual product remains safe as it ships from port to port.
Yeah, so that's a great question. The government interest in this is obviously for things like shipping. The ultimate is for border security. But for government use, it's for protecting shipments of government material for the Department of Defense and others. And oftentimes they're not as worried about theft, although obviously if somebody steals government equipment or weapons, that is clearly a serious problem. But they're concerned with tampering, because sometimes if you tamper with something, you can either gain information or tamper with a weapon that will cause a weapon to malfunction. So that's an issue. And obviously those risks are such that the government may be willing to pay a lot for it. For instance, our container right now for government use can detect a penetration 1 inch or greater in diameter on any of its sides with 99% probability of detection. That's pretty tight. So what we're looking at right now is for commercial shipping, commercial shippers aren't necessarily as concerned with tampering. They're concerned with pilferage and theft. And pilferage and theft are, do you need a 1 inch probability of detection for pilferage and theft? No, you can probably make that a less sensitive sensor. And there are other things that lead towards reducing the cost of that container. And what we're doing right now, and this is with DHS funded research, we are building containers and putting them out there with commercial clients so that they can identify what's the value to them. They'll be shipping things as advanced electronics. A container full of iPads obviously probably has a really high value. A container full of Louis Vuitton purses has actually a really big value. A container full of chemicals as precursors to pharmaceuticals has a really big value. So what is our ability to, what's the pilferage and what is our ability to stop that and prevent that? Right now, there's something on the order of $50 to $60 billion per year of containerized cargo lost or stolen every year. And users and shippers are often shipping $1 million plus cargo, and that can be lost. So what we're in the process right now for the next few years, in addition to producing for government, is producing some for commercial and commercial use, and really finding out the use case, and then figuring out how do we tailor the engineered container and the cost of that to get the best use case at the lowest cost for commercial. And that's what we're in the process right now.
It's so interesting because it sounds like you're on the cusp of another revolution in shipping. So, you said in the 50s, we went to containerized shipping. And I remember at the turn of the century, oh, so long ago, all these people had different lists about what was the most important invention in the 20th century. And an argument was made for the cardboard box, right? Like for much the same reason of containerized, it made it a shape that was easy to manage, right? But it seems like you're on the cusp of something here where you could have, depending on the client and what is being shipped, you could really have different gradations of the containers to meet a really wide range of audience and hit the sweet spot in all these different places. I mean, is that kind of what you're trying to test out, is to figure out who needs what degree?
Right.
And not just cost, but like you could go overboard easily, right?
Well, the government may be willing to pay for a container because the cost of tampering is so extreme that eliminating that risk or reducing that risk is worth quite a lot. Commercial shippers, their business. And so obviously the cost of using a secure container is going to be more than the cost of a standard steel container. What does that do for your bottom line in terms of reducing your losses, reducing your insurance, reducing any additional pilferage theft? All of that, improving your operations, because the containers not only provide security, but they also let you know where they are. So you, at that point, you have a container on a ship or on a train or on a truck. And if you as the shipper are wondering, when's that thing going to get? My customer just called up. When am I getting my shipment of iPads? You can actually go online on your portal and say, okay, that's actually coming into the port right now. And you can provide real time. So that is revolutionary. The question that we're seeking to answer in the next few years is, what level of security and awareness and reporting does the commercial industry need? And what cost are they able to bear that will add value to them?
So what has surprised you the most about your path here with bridges and buildings are cool to really deeply embedded sensors and I'm going to watch it like ride up the highway? What, has there been a surprising experience you've had in the span of the last 30 years that you truly didn't see coming?
Well, let's take it back to sometime in June of 1987 when you and I were sitting with graduation caps and gowns. If somebody told me that you're going to be a PhD and a CEO, I would ask them, what are they on? The entire trajectory of my career has been very interesting and exciting. And each time it was a surprise. I discovered that I really enjoy working with large structures. That got me through a degree in the Maine DOT. And then an exposure to R&D got me into a 17-year R&D career. Until that exposure, I never would have guessed. An exposure to business during that time got me into business opportunities in the Research Triangle and elsewhere that have since brought me back. At each evolution, it's been like, well, this makes sense. But when I look back at it, I say, I never could have seen that coming. So it's all been a surprise. I'm looking forward to what's coming around the corner, the next evolution.
I think it's a good reminder for all of us. First of all, don't go with this preconceived notion that you know what your whole life is going to be, but also just be open to trying new things. While I was in college, I thought I might want to go to law school. So I got to do a summer internship at a law firm. And best thing I ever did, because I learned there was no way I wanted to do that. And that was actually a huge surprise to me. Like, oh, dodged a bullet there, but now what am I going to do kind of thing. So I think it's really important to keep yourself open to that. All right. Well, Bob, I don't want to take too much more of your time. I feel like I've totally taken advantage of our long-time friendship, which I'm totally happy to. I'm glad to have done it. I don't think I've had any conversations with anybody up until now that involved both kind of deep structural engineering and sensors. I talked with Ali Abedi a couple of years ago, but his is not structural engineering. It's deep into sensors, but it's electrical engineering. So it's kind of neat to see these things cross in ways just in one person's experience and what they're doing. So I really appreciate your time. I'm really glad that you're back in Maine. I think it's good for Maine. It's fun for me on a personal level, but I think the work you're doing is really, really cool. So thank you.
Thank you for the opportunity to speak with you. And as always, my friend, anytime.
Thanks for listening to the Maine Science Podcast. Make sure you never miss an episode by following us on your podcast platform of choice. And please leave a rating and review. It will help more people find us and help spread the word about some of the remarkable people doing science in Maine. The Maine Science Podcast is recorded at Discovery Studios at the Maine Discovery Museum in Bangor, Maine. The Maine Science Podcast is executive produced and hosted by me, Kate Dickerson, and edited and produced by Scott Loiselle. And the Discover Maine theme was composed and performed by Nick Parker.